Hello, kiddos. We're talking about the refrigeration gauges today. Um, I'm going to name some of the components of the refrigeration gauges and the reasoning behind it. Um, First, we're going to start with the color. If you'll notice, this says low. Most gauges doesn't tell you low or high, but you can always tell low because low is blue and the high side is always red. Also, if you'll look right here, on the PSI, the black area right here, that's the PSI. And the blue side goes up to 220 PSI. And the red gauges, which is the high side, goes up to 500 PSI. Okay, and it's the black area. This is the pressure number on the outside. The stuff on the inside here, and I'm going to focus in on it. See if I can focus in on it so you can see it better. The parts inside here, uh, I should have talked to you about pressure temperature gauges charts already. Well, you don't really need a chart a lot of times if you have a set of gauges like this because they put the chart within the side, the gauges. Now here's the pressure, the PSI, outside, and the inside is the temperature of the particular refrigerant. For instance, R134A is the green, the blue is R12, and the red is R22. Same way on both sides. Red R22, blue R12, and then 134A on the outside. And these are temperature readings, not pressure. So for instance, if this gauge was pointing at 70 psi, which would be right here, if this needle was in that direction right there, it says that at 70 psi, 134A would be 70 degrees. R12 would be just under 70 degrees. It'd be like 68 degrees. But look right here. R22, which is the normal refrigerant in most houses at this time, it's 40 degrees. You remember when on the board, when I was taking you through the tour of an air conditioning circuit, that the evaporator should be at 40 degrees. So if the evaporator is 40 degrees, your refrigerant should, at 70 psi, should be 40 degrees. All right? So that just gives you an idea. Example over here, if the pressure is 250, let's aim for 250 right here and right here. R22 should be 120 degrees. Or R12 should be 156 degrees. And R134A should be about 58 degrees. All right. So that just gives you an idea what the temperature of the refrigerant should be. Okay. We're going to also talk about, that's just talking about the inner part of the gauge. One more thing, this little device right here on both sides, this is how you calibrate your gauges. Make sure your gauges needle always points at 0 before you hook it up to the system or have any pressure on it, right? One other thing to notice on the gauges is this is 0 on the low side. So anything this side of the 0 is a vacuum, and anything this side is pressure, PSI. But if you'll notice over here, the high side does not have it, right? So high side never operates in the vacuum. Now, there is a possibility for the low side to operate in a vacuum. We also use the vacuum scale for when we're evacuating the air and getting ready to charge the system with refrigerant. You first have to remove the non-condensables and air and moisture out of the system before you can put refrigerant in it, and that's what you would use a vacuum pump for to help you do that, help you dehydrate the system. Okay. I'm going to back it out again so we can talk about the other parts to it. And I'm going to reduce it for a second and erase what I wrote. I'm sorry for the time it takes to do that. And then I'm going to open it back up. Okay, now, sorry. I need to put the pen again. Okay, now open that. Now, on here, you have a line, just like we were talking about the air conditioning circuit. This side is the low side, which the handle tells you that, and this side is the high side, just like on the air conditioning circuit, okay? This part right here is a sight glass, and I'm going to tell you why we use a sight glass. This is a valve, which is a metering valve. Metering valve. Okay. The reason why is, okay, if we're using a pure refrigerant like R22, the sight glass means nothing. Okay, it means nothing to us other than to see that refrigerant's coming in or we have no refrigerant coming out, that is completely dehydrated or condensables or whatever. Other than that, it really means nothing. All right. So this line, the yellow line, would be either attached to the refrigerant or the vacuum pump. Right? One or the other. If we're dehydrating the system, we would have the yellow line hooked to the vacuum pump. If we were charging the system, we would be hooked up to a refrigerant can, right? And we would be charging the system. And the refrigerant goes in this direction, okay? If I'm charging liquid into the system, I'd go this direction. If I was charging a vapor, I would go this direction. You do not charge liquid this way. No liquid. This would damage the compressor because this would actually go straight to the compressor. We would not put vapor on this side because this goes into the meter device, but this would be the liquid side. Okay, vapor side and liquid side. Okay. Now, it has been told to you, you have read that blend refrigerants, when you have more than one refrigerant combined together and make one refrigerant, that you must charge go in as a liquid and come out as a vapor. Well, that's where the sight glass comes in. When we let we set the can up to where it lets liquid out into the line, into the yellow line. Okay. Sometimes it means you got to put it upside down, and then there's some cans that are already set up. Even if you when you set it up in the right position, it comes out liquid no matter what. But there's still old cans out there, so the old cans you have to turn them upside down. All right. But just look on the can and read it, and it'll show you. They'll have an arrow on the can that says, "Hey, this end up for liquid or this end up for liquid." Okay, so make sure you pay attention to that. Well, right here, this little valve here, when you have the liquid, you open it up and you allow liquid in just enough to keep this side glass halfway full, and then the other side as a vapor. What you're doing is you are charging into it as a liquid, and then all the liquid inside the sight glass vaporizes and then goes into the sight glass. Into the low side. Okay, and that's how we use a sight glass. Now, if we're charging into the liquid, then this sight glass can be full. So if we charge this direction, then that sight glass can be full. But if we're charging this way, the sight glass has to be halfway. Only halfway full. It can only be halfway full because we want to make sure when it goes in, it comes out as a vapor. So if half of this is only liquid, the other half is vapor. That makes sure that nothing but vapor is coming out. And how do you control how much is in that sight glass? Is this little valve right here, the metering valve right here. Okay. So again, this hose is the low side, so it goes to the low side of the system, which is the larger copper tubing on the condenser. This goes to the high side, the discharge line, which is the smallest tube going into the condenser. All right. And remember, the yellow line is either hooked up to a vacuum pump if you're dehydrating the system, or a refrigerant can if you're charging the system. And remember, blue is the low side, red is the high side. So hopefully this was a good understanding. Oh, one other thing before I get out of this is that um, to quickly evacuate the system or dehydrate the system, sometimes you would put a bigger line on here. This is in the core. They talk about sometimes when you have a larger evacuation line. This is the line that they're talking about, the yellow side. So if you put a bigger line than this on there, that would help speed up the dehydrating the system so you can charge it. All right. See you on the flip side.